Good morning. Today and tomorrow we're going to be taking a look at absolute value. Absolute value is the distance from zero on a number line. So today we're going to take a look at what the graph looks like, talk about domain and range, look at transformations, and then tomorrow I will show you how to solve an absolute value equation. So absolute value is the distance from zero on a number line. So let's go ahead and jump into what it looks like in Desmos. So in Desmos, this is my parent absolute value function. So it's the one that's here in the green. When you graph an absolute value function, it should make a V. So absolute value is actually a special type of piecewise function. So there's actually three sections to this graph, believe it or not. So the first section is the negative slope that's coming down all the way to the origin. So that's one section of the piecewise function. The middle section is actually just one dot right here at the origin. And then the third section is the positive slope that's going up on the right-hand side. So absolute value is a special type of piecewise function. So it makes a V when you graph it. Let's talk about domain and range. The domain for an absolute value function is going to be all real numbers. It's going to extend over forever and always over to the left-hand side, and it's going to extend forever and always over to the right-hand side. So your domain is all real numbers. Let's talk about what the range is. Your range is not all real numbers. Your range, it never gets below this line right here. So your range is anything that is greater than or equal to 0. So range for an absolute value function is greater than or equal to 0, unless I move it up, down, left, or right, or do something like that. But for my parent function, domain all real numbers, and range y is greater than or equal to 0. So we're going to go through and look at our transformations, and then at the end we'll have a little conversation about what they mean. So make sure you follow along to different colors and different things that we're doing so we can see if my graph is moving left, right, up, down, stretching, flipping, all that good stuff. So if I look at this function right here, this is my parent function. Let me highlight number 2. So this purple one that just appeared. So f of x equals 3 times the absolute value of x. You should notice that from the parent function, the one in the green, to the purple one, it got skinnier, so to speak. This is actually a vertical stretch. So think of a rubber band. So this is a vertical stretch by a factor of 3. So I got the 3 right from the equation that I highlighted. So this is a vertical stretch by a factor of 3. If I look at the next one, let's see what color this is going to be. This is like in the black color. So the green is our base. So make sure you keep that in mind. Green is the base. Look at what happened with the black. So the black one got wider. This is actually a vertical shrink by a factor of 1/3. So I use the analogy of rubber band. If you stretch a rubber band, it gets skinnier. So that's the purple. That's why it's a vertical stretch. And then the 1/3 is a vertical shrink because it actually got wider. So if you have a number in the front, if your number in the front is bigger than 1, it's going to be a stretch. And if it's a fraction between 0 and 1, it's going to be a shrink. So keep that in mind. All right, let's see what else we got in store. So let me get rid of those. Let's take a look at our next one. So the green one is our parent function. Let's see what happens when I add a negative in the front. And you probably already guessed that one. The negative in the front is going to flip it over the x-axis. So the green is my parent function. When I added a negative in the front, it reflected over the x-axis. Okay, let's see what happens now. So this is my parent function. This is what I'm basing everything off of. Let's see what happens when I do the absolute value of x plus 4. So notice the absolute value of x plus 4 moved to the left 4 spaces. So that's the one that I just highlighted. The origin is 0, 0. We moved left 4 spaces. So you probably can guess what's going to happen to my next graph if we do x minus 5. Notice x minus 5 moved to the right 5 spaces. So both of these colors are green, but the one that I'm going to highlight here, the absolute value of x minus 5, is this one here, and it moved to the right 5 spaces. So if you have a number on the inside, it's the opposite of what you think. So this x plus 4 actually moved left 4. This x minus 5 actually moved right 5. Okay, let's see what else we can make it do. Again, this is my parent function. So let's see what happens if I do the absolute value of x minus 3. Notice it moved down 3 spaces. So it moved down 3 spaces. It started at the origin and it moved down 3. And so you probably can imagine if I do the absolute value of x plus 4, notice the black one that just popped up, it moved up 4 spaces. Now, notice I just kind of talked our way through these. I'm hoping that you notice that these transformations are the same transformations that we studied earlier in the semester. So regardless of your function, if you have a number on the outside, it's going to move it up or down. If you have a number on the inside of any kind of grouping symbols, it's going to move it left or right. The negative is going to reflect it across the x-axis. A number in the front is going to stretch it or compress it. So these transformations are the same transformations that we studied earlier in the semester. They're exactly the same. So let me just try one more in here. So let's see what happens if I have a whole bunch of transformations at the same time. I'm going to keep the parent function in there, and I'm just going to make up some numbers and type in. Let's make it do -2. Your absolute value is down here at the bottom where the A is. You can type in X. Let's do -3, and then let's do +5. So 4 different things happen to this graph. So 4 different things. The negative made it reflect across the x-axis. So notice I now have an upside down V. The 2 is a vertical stretch by a factor of 2. So it's skinnier than the original one. So my V is not as wide, it's skinnier, it's a vertical stretch. The x minus 3 moved right 3 spaces. So right 3 spaces. And the +5 moved my whole function up 5 spaces. So you should be able to distinguish what number, what effect that has on the graph, and then you should be able to make up your own graphs if I give you a characteristic.